Bismillahirrahmanirrahim. Okay, we will continue with 1.2, which is mole concept. You can read the objectives on your own. Mole. In daily life, we count objects in units such as dozen and pairs, which one pair of shoes, we know that it is equal to 2 shoes, right? How about if we have 1 dozen of eggs? 1 dozen of eggs means we have 12 eggs. In chemistry, we measure the amount of substance in mole. The symbol of mole is mole or N. So 1 mole of any substances contain 6.02 times 10 to the power of 23 particles. So particles can be in the form of atom, molecule, or ion. So what is the definition of mole? A mole is an amount of substance that contains the same number of particles in exactly of 12 gram of carbon-12, which is 6.02 times 10 to the power of 23 particles. So what is this? This is what we call Avogadro constant or Avogadro's number. It is stated also at the front page of your tutorial booklet. So 1 mole of carbon equals to 12 gram, and it is equals to 6.02 times 10 to the power of 23 of carbon atoms. The particles need to be carefully specified. Either it is an atom, molecule, or ion. So atomic substances. For elements, the particles are atoms. So all metals such as copper, zinc, and sodium are metals, which the particles are atoms. All noble gases also, such as argon, helium, and neon, also in the form of monoatom. So let us look at the example of this sodium. So 1 mole consists of 23 gram of sodium, which it contains 6.02 times 10 to the power of 23 of sodium atoms. How about molecular substances? So for covalent compounds, the particles are molecules such as water and carbon dioxide, or to certain non-metal elements such as oxygen, bromine, and nitrogen, which is also contain 6.02 times 10 to the power of 23. Okay. Since we have iodine molecule here, contain 2 iodine atoms, so that's why we have 2 times 2 here. Next is the ionic substances. For ionic substances, the particles are ions, such as, for instance, we have sodium chloride, zinc bromide, potassium iodide, and magnesium chloride. How can we get this 58.5 gram? It is come from the molar mass of sodium, which is 23, while for chlorine is 35.5. So you plus this 2, so you have, it is 58.5 gram, the molar mass of sodium chloride, which it contains 6.02 times 10 to the power of 23 of NaCl. Which means we have 6.02 times 10 23 of sodium atoms with also 6.02 times 10 to the power of 23 of chlorine atoms, made up of 1 mole. Then next, mole and particles. So 1 mole of any substance is equal to how many particles? It is 6.02 times 10 to the power of 23 particles. So for 1 mole of magnesium contain these magnesium atoms. 1 mole of fluorine molecule. How about 1 mole of fluorine molecule? Since we know that fluorine molecule contain 2 fluorine atoms, so that's why you have 2 times 2. So 1 molecule of fluorine is made up of 2 F atoms. How about ammonium ion? Ammonium ion, we have 5. We have 2 times 5. Huh? We have 2 times 5. Why? Because we have 1 nitrogen atom with 4 hydrogen atoms. That's why we have 2 times 5. Times 5. Because 1 mole of ammonium ion consists of 5 atoms. Next, the molar mass of substance is the mass of a substance that contains 1 mole of the substance. 1 mole of substance contains 6.02 times 10 to the power of 23 particles. And hence, the molar mass of any substance contains 6.02 times 10 to the power of 23 particles. The mole atom is numerically equal to its relative atomic mass or relative molecular mass, which we express it in gram. Hence, we can easily calculate the mass of any number of moles of a substance. Let's have example 1. You have to calculate the mass of ammonium carbonate that contains this mole and this hydrogen atoms. 2 mole of ammonium is equivalent with 1 mole of ammonium carbonate. Why? Because we have this ammonium ion, which is NH4 plus 1 with carbonate ion, which is CO3 2 minus. When you cross, you have the mole for ammonium ion is NH4 2 mole and 1 mole of carbonate ion. So that's why you have to put 2 here, which means 1 mole of ammonium carbonate has 2 mole of ammonium ion. If we have only 0.3 mole of ammonium ion, it will be equivalent with 0.15 mole of ammonium carbonate. You have to solve your proportion, perkadaran. Proportion means perkadaran. This means we have the equivalency between the ammonium ion with the ammonium carbonate. Since the question is asking you to calculate the mass, what to do is of course 2 times with the molar mass of the ammonium carbonate. So the final answer is 14.4 gram. How about question B? Question B is asking you to calculate the mass of ammonium carbonate that contains these H atoms. So how can we solve this? We know that 1 mole of ammonium carbonate contain 8 mole of H atom here. 4 times 2, right? Which this is equivalent with 8 times the Avogadro number in order to get that number of H atoms. So this is the amount of H atoms, bilangan H atoms. If you have 6.02 times 10, 23, so it will be equivalent with how many mole of ammonium carbonate? So how to solve this? 6.02 times 10 to the power of 23, you divide by this 8 times that Avogadro, okay, times 1 mole of ammonium carbonate. Then you have the answer of mole of ammonium carbonate. How to get the mass? Is of course 2 times with the molar mass of ammonium carbonate. So the mass of ammonium carbonate is 12 gram. How about the number of moles of any gas? It is determined by measuring its volume. The molar volume of a gas is defined as the volume of 1 mole of the gas. So 1 mole of gas contain 24 liter or 24 dm cube. If we have 2 moles of gas, is equal to how many liter of volume? How about if we have 10 liter of gas? What is the mole of the gas? let us look at the difference if you have to calculate the mole of gas in both at room temperature and also at STP. What is STP? It is standard temperature and pressure, which the temperature and pressure are at 0 degrees Celsius and at 1 atm, which 1 mole of gas contain 22.4 liter of that gas. How about at room temperature and pressure? It is at 25 degrees Celsius and 1 atm. If it is at room temperature and pressure, 1 mole of gas contain 24 liter or 24 dm cube. Avogadro's law states that the equal volumes of all gases contain the same number of molecules under the same temperature and pressure. This is the interconversion between the mole, the mass, the number particle, the volume of the gas, and also the volume of at STP and at room condition. So the key here, you have to determine the number of moles. Then only you can convert into mass in gram or the volume, or to calculate the number particle, or to calculate the volume still, but it is in room condition. So remember, 1 mole of gas equals to 22.4 liter gas if it is at STP. Okay. Since we know that 1 mole of C2H2 equals to 22.4 liter at STP. 1 mole of this C2H2 contain 22.4 liter of C2H2 at STP. How about if we have only 0.6 mole? Simply times 22.4 liter. So the answer is 13.4 liter at STP. How about if it is at room temperature and pressure? Like I have mentioned in our previous slide, which 1 mole of gas contain 24 liter gas at room temperature. If you have only 0.6 mole of C2H2, what to do is to times with 24 liter, so you have 14.4 liter at room condition. Let us proceed to next example, which is example 2. Example 2, we have to determine which container contains more molecules. Is it the container with 14.9 liter of gas X at STP, or the container with 15.9 liter gas Y at room temperature? What to do is to, of course, to calculate both mole number for both gas X as well as gas Y. So as usual, for STP, you have to divide by 22.4. Then you have the mole for gas X. How about gas Y? You have to divide by 24 at room temperature. So you have this mole of gas Y. We know that 1 mole of X contains 6.02 exponent 23 molecule of X. If you have this mole only of 0.665 mole, so how many molecule of gas X present? So this will be equivalent with 4.003 times 10 to the power of 23 molecules of X. How about gas Y? Once you have done the mole for gas Y, which is 0.663 mole, how to get the number of molecules of gas Y? Typo. Okay, sorry. This should be molecule of Y. So 0.663 mole of gas Y. Okay, divide by 1 mole times with 6.02 times 10. 23 molecule of Y. So the answer is 3.991 times 10 to the power of 23 molecules of gas Y. So, which container contain more molecules? Is gas X. Let us proceed to the empirical formula and molecular formula. Empirical formula. What is empirical formula? Empirical formula is a chemical formula that shows the simplest whole number ratio of atom of elements in a molecule. So the key here is the simplest whole number ratio. How about the molecular formula? It is the actual number of atoms of each element in that molecule. How about the relationship between empirical formula and molecular formula? It is given by empirical formula and equals to the molecular formula, which N is equal to the molecular mass of the compound divided by the empirical mass of the compound. For instance, we have C3H4O3 is the empirical formula, which is the simplest whole number ratio. Right. Since the value of N equals to 2, so what to do is to times 2 for each of element. So 3 times 2 is C6, H4 times 2 is H8, 3 times 2 for oxygen is 6. Let us look at example 1, ascorbic acid, commercially known as vitamin C, which cures scurvy and may help prevent the common cold. It is composed of 40.92% of carbon, 4.58% of hydrogen, and 54.5% of oxygen. Since you are given in the form of percent, so you have to insert here the mass is assumed is in 100 gram. Simply insert the percent is the mass in gram for each of the element. Then you find the mole. Okay, divide by the molar mass of each of element. So carbon, the molar mass is 12. For hydrogen is 1, oxygen is 16. Then you have the answer mole. You find the ratio by divide the smallest value. So which one is the smallest value? Is 3.40. Right, okay. Then you divide by the smallest value. You have the answer is equals to 1, 1.34, and this is 1. Okay. Then find the simplest ratio. Since you cannot simply round off into 1. No, never round off. Simply round off into 1. But you have to find a factor times with that factor. Kan? Okay. So you have to find the factor times with that factor until you get the whole number. So it is approximately equals to 4.02. So equal to 4. So what is the simplest ratio? It is C3H4O3. Remember, never round off values close to the whole number in order to get the simple ratio. But you have to find a factor. Multiply the value by a factor until you get the whole number. Okay, you cannot simply round off. You have to find a factor, then you times with that factor. Calculating. So how can we calculate the molecular formula? Given in the question, the molar mass just now is 176. So what to do is to find the N. Then and insert it here. So your molecular formula is C6H8O6. Next example we have is in the form of hydrated compound, which is hydrated calcium chloride. You are given 18.3 gram sample of hydrated calcium chloride contains 4 gram of calcium, 7.1 gram of chlorine, and 7.2 gram of water only. Determine its empirical formula. So how to write the empirical formula is this way. Generally, it will be written as calcium X Cly dot ZH2O. Okay. Now, you have to determine its empirical formula. Means you have to determine what is your X value, Y, and also the Z. Okay. You insert that mass is 4 gram for calcium, chlorine is 7.1, while water is 7.2, as given in the question. Then you find the mole for each of calcium, chlorine, and water, respectively. Right, divide by the molar mass. For calcium is 40, chlorine is 35.5, while water is 18. Okay, then you find the ratio and the simplest ratio as well. 0.1 divided by 0.1 equals to 1. 0.2 divided by 0.1 equals to 2. 0.4 divided by 0.1 equals to 4. So the answer is 1, 2, and 4. So this is the way how you write the empirical formula of your hydrated calcium chloride. Done for example 2. Next, we will look at the concentration measurements, which you have to define each of the following concentration measurements. Molarity, which are molarity, molality, mole fraction, the percent by mass, and also the percent by volume. And then you have to calculate each of concentration measurements. Solution. So what is solution? A solution is a homogeneous mixture between a dissolved solute and solvent. What is example of solvent? Example of solvent is water. How about solute? Sodium chloride. So when you have dissolved solute in the solvent to form the NaCl solution. Okay, the concentration of solutions is the quantity of dissolved substance, the dissolved substance per unit quantity of solvent or solution. Concentration is measured in various ways, such as molarity or molar concentration. The symbol is capital M. Molality, the lowercase m. Mole fraction, which the symbol is X. Percent by mass, okay, percent weight per weight, or percent by volume, which is percent volume per volume. Okay, let us go to molarity first, which this you have learned since Form 4, I bet, right? Okay, let us go to the definition of molarity first, which molarity is the number of moles of dissolved solute in 1 liter or dm cube of the solution. So you have to consider the mole number of solute in the volume of solution must be in liter. The symbol is C, stands for concentration of the capital M. The unit is mole per liter or mole per dm cube or simply M. Must be capital M. Note here, 1 liter equals to 1 dm cube, which 1 dm cube is equal to 1000 cm cube. How about 1 mil? 1 mil equals to 1 cm cube. Okay, let's have this first example. A matriculation student prepared a solution by dissolving this mass of sodium carbonate in 250 ml of water, which you have to calculate its molarity, since we have to consider the mole of solute. So what do we have in this system? We have sodium carbonate, which is the solute. The solvent is water. Water is the solvent. What is the solution? Solution is the sodium carbonate solution. So what to do? The first step is of course to find the mole first. Then to convert the volume solution given in liter. Then only you can insert it here in the formula. Then you have the answer is 0.2331 mole per liter or mole per dm cube or m. Next is molality. So molality is something new for you, right? Okay, let us look at the definition of molality first. What is molality? Molality, still we have to consider the number of moles of dissolved solute. molality, still the number mole of solute. But this time it is in kilogram of solvent. Solvent usually will be water. So you have to determine the mass of solvent, which is water, in kg. The symbol for molality is m, lowercase m, which the unit is mole per kg because we insert it here, the mole of solute, which is in mole, of course, divided by the kilogram of solvent. So the final unit, of course, is mole per kg, or write the word molal, or you can also write m, the lowercase m. Note here, mass of solution is equal to the total mass of solute plus the mass of solvent. But the volume of solution is not equal to the volume of solvent. Let us look at the next example, which is example 2. You have to calculate the molality of ethylene glycol containing 8.4 gram of ethylene glycol in 200 gram of water. So what do we have in this system? What is the solute? Solute is the ethylene glycol. How about the solvent? Solvent is water. What is the solution? Solution is, of course, the ethylene glycol solution. So what to do is, of course, to find the mole of ethylene glycol first, which is 0.1355 mole. What to do with this 200 gram of water is, of course, to convert it into kilogram. Then only you can insert it in the formula. So insert, then you have the final answer is 0.6775 mole per kg, or you write the word molal, or simply lowercase m. So any unit is accepted. Next is the mole fraction. What is the symbol of mole fraction? The symbol for mole fraction is capital X. What is mole fraction? Let us go to the definition first, which the mole fraction is the ratio of the number of mole of one component to the total number of mole of all components present. The symbol is X, remember, and it has no unit. The mole fraction is not equal to the number of mole. Careful, mole fraction is not equal to the number of mole. Mole, yes, you have the unit mole. But when it comes to the mole fraction, pecahan mole, put no unit. Careful. Please note that X, the mole fraction, must always smaller than 1. If you have the answer X mole fraction is more than 1, means the working step is wrong somewhere. The total mole fraction must be equal to 1. So mole fraction of component A plus the mole fraction of component B plus the mole fraction of component C equals to 1. Next, let's look at the example 3, which you have to calculate the mole fraction of copper chloride in the solution, and also the mole fraction of water. So the question is asking you to calculate both mole fraction of copper chloride and the water as well. What do we have in the system? What is the solute? Solute is the copper chloride. That is component 1. Component 2 is water. What to do is to calculate the mole of water as well as the mole of copper chloride. Okay. Oh, you don't have to calculate the mole of copper chloride. It is given in the question already. So it is easier for you to solve this question. Okay, then mole of water. How can we get the mole of water? Is of course to divide by the molar mass of water. So the mole of water is 40 mole. Mole fraction of copper chloride equals to mole copper chloride divided by mole total. What is mole total? Mole total is mole copper chloride plus mole water. I prefer you write this way instead of N total. Huh? So write this way of mole copper chloride divided by mole copper chloride plus mole water instead of write N total. Okay, so 0.3, it is also 0.3 here, plus 40 mole of water. Then this is your mole fraction of copper chloride. Since we know that the total of mole fraction of copper chloride plus mole fraction of water equals to 1, right? Since you have done this mole fraction of copper chloride, so how to get this mole fraction of water? 1 minus answer. 1 minus answer just now. Okay, this way. So you have the mole fraction of water is 0.9926. Or you can insert, okay, the same goes for to find the mole fraction of water, which you have to consider the mole of water. Then here you have to insert N copper chloride plus N of the water itself. Okay, 40, 0.3 is given in the question, so will be the same answer. Next is percent by mass, which is percent weight per weight. Is the ratio of mass of solute to the mass of solution times 100. The symbol is this, percent weight per weight. Example, if you are given statement 10% weight per weight of NaOH, what does this mean? This means we have 10 gram of NaOH, the dissolved solute, in 90 gram of water, made up of total 10 plus 90 is equal to 100 gram of solution of NaOH solution. Why? Because the mass of solution equals to the mass of solute plus mass of solvent. Okay, next is example 4. You are given the sample of 0.892 gram of potassium chloride dissolved in 54.3 gram of water, which you have to calculate the percent by mass of KCl in this solution. What do we have in this system? KCl as the dissolved solute, water is the solvent, KCl solution is the total solution, the KCl plus water. So KCl solution made up by that KCl plus water. Mass solute KCl is given, the mass of potassium chloride given in the question. So we know that mass solution equals to mass of solute plus mass of solvent. So simply insert, then you have the mass of solution is this, 55.192 gram. Insert it here, the mass of solute in the question. Then you have the answer, percent weight per weight of KCl is only 1.62%. Next is percent by volume. The symbol is percent volume per volume. The ratio, which the percent by volume is the ratio of volume of solute to the volume of solution times 100. So volume of solute divided by volume of solution times 100. Example, if we have 5% volume per volume of KCl, this means we have 5 ml of KCl dissolved in 95 ml of solution. Next example is example 5. A 200 ml of perfume contains 28 ml of alcohol. Calculate the percent by volume of alcohol in this solution. Volume solute, which is the alcohol, is 28 ml given, right? While the total solution, the total volume of solution is 200 ml. So simply insert the answer. Percent volume per volume is 14%. So the percent of alcohol that contained in that perfume is only 14%. How to relate the density of solution to the concentration measurement? Density, the symbol is rho. So rho of the solution. The symbol for density of solution, okay, which the density of solution is equal to the mass of solution divided by the volume of solution. So the unit can be in gram per liter or gram per dm cube or gram per mil. It depends on the question. Example 6. A solution of hydrochloric acid with 37.8% by mass of HCl. What does this mean? This means we have 37.8% of HCl in 100 gram solution. So mass of HCl is 37.8 gram, while mass of solution is 100 gram. Okay. How about mass of water, the solvent? HCl is the solute, which is 37.8 gram. Solution is 100. Right. How about water? Water, the solvent. The solvent, water, will be 100 minus 37.8 gram. Okay. Which the question is asking you to calculate the molarity of concentrated hydrochloric acid. How can we calculate the molarity? Molarity. Get back to the definition of molarity. Molarity must consider the mole of solute. So which one is a solute? Solute is HCl. Divided by volume of solution must be in liter. Right? Okay. How can we calculate the mole of solute? You have the mass already. Right? So what to do is to find the mole of HCl. 37.8 gram divided by the molar mass of HCl. Molar mass of HCl is 36.5. So you have the mole of HCl. Right. Okay, we are done at the first part. Mole of dissolved solute. How about volume of solution? How can we find the volume of solution? Since density is given to you is 1.19 gram per mil here in the question, okay, the density given is in gram per mil. What is this 100 gram? 100 gram is the mass of solution. Remember, the mass of solution is 100 gram? Right, so insert it here. Okay. Then of course you can find the volume of solution. What is the unit of the volume of solution? Is of course mil. Why mil? Because you are given the density is also in mil. What to do is then to convert into liter. Why? Because the molarity must consider the volume of solution in liter. So insert the values. Then you have the final answer is 12.3 molar. Let us look at the exercise. Density of 10.5 molar NaOH solution given to you is 1.33 gram per mil. What is meant by this 10.5 molar? Let us go back to the definition of molality. What is molality? Molality, you have to consider the mole of solute. So what do we have in this system? NaOH as the dissolved solute, water as the solvent, while solution is that sodium hydroxide with water made up the NaOH solution. Okay, molality means you have to consider the mole of solute divided by the mass of solvent in kg. Right. So when you are given that 10.5 molar means it is 10.5 mole of solute in 1 kg solvent. The question A is asking you to calculate the mole fraction of NaOH. What is the symbol of mole fraction? It is capital X. X NaOH, which it is equal to the mole number of NaOH divided by mole total. Mole total equals to NaOH plus N water. So you have to find the mole of water. You have the mole of NaOH, right? Here, 10.5 mole. So you insert here. Here. How about mole of water? How to find the mole of water? So mole of water equals to 1000 gram. This one, 1 kg, you convert into 1000 gram. Divide by the molar mass of water, which is 18 gram per mole. So what is the mole of water? It is 55.556 mole. Then you insert both for NaOH plus the mole for water as well. And the answer is 0.159. Next is to determine the percent by mass of NaOH. How can we determine the mass of, how can we determine the percent by mass of NaOH? How to find the percent by mass of NaOH? Means you have to consider the mass of NaOH divided by the mass of solution times 100. Do we have the mass of NaOH? No, but we are given the mole, right? Okay, so how can we determine the mass of NaOH? Just now we know that the mole is 10.5 mole. So what to do with this? How to find the mass of NaOH is 2 times with the molar mass of NaOH, which is times with 40 gram per mole. And the answer is, you cancel off mole and mole negative 1. Answer mass of NaOH is 420 gram. Next is to find the mass of solution. How about the mass of solution? Mass of solution is equal to the mass of solute, which is NaOH, plus the mass of solvent, right? Do we have the mass of NaOH? Yes, it is 400, It is 420 gram plus the mass of water. How about the mass of water? How many gram of water just now? We have 1 kg, which is 1000 gram. Therefore, the total mass of both made up the mass of solution is 1420 gram. Then you insert both of 420 gram divided by this 1420 gram in this formula. So, the percent by mass of NaOH is 29.58%. Next question is C. Let us proceed to question C to find the molarity of solution. So how to find the molarity of solution is to consider the mole of NaOH divided by the volume of solution in liter. Do we have the mole? Yes, just now is 10.5 mole of NaOH divided by the volume of solution in liter, right? The question is how to find the volume of solution in liter. Since you are given the density of solution is 1.33 gram per ml, which we know that density of the solution is equal to the mass of solution divided by the volume of solution, right? So you insert it here, 1.33 gram per ml equals to mass of solution. So how many gram of mass of solution just now is 1420 is the mass of solution. So insert it here. So what is the volume of solution? It is 1067.7 ml, which then you have to convert into how many liter? So it is 1.0677 liter. So insert it here, 10.5 mole divided by the volume is 1.0677 liter. Then the final answer is 9.83 molar or mole per liter. That's all. Thank you.